What happens when our most advanced space monitoring technology captures an image that, just totally defies explanation, only for the data feed to be severed at that precise moment? On June 18th, NASA's live stream tracking 3I Atlas, our solar system's third interstellar guest, transmitted a single baffling frame. It showed an object with characteristics that appeared honestly, unnervingly artificial, then nothing but static. The official report cited network failure, but cryptographically verified data from independent archivists confirms the image is real. So what was that razor-sharp glint in the void? Let's analyze the data together. The initial discovery. The story begins with a technological marvel of planetary defense. On July 1, 2025, the Asteroid Terrestrial Impact Last Alert System, a network of robotic telescopes better known as ATLAS, triggered an alert. This NASA-funded system, with University of Hawaii's Larry Deno as its principal investigator, scans the entire night sky every 24 hours. Its primary mission is to find near-Earth objects, but on this day, its algorithms flagged something extraordinary. The object's trajectory was hyperbolic, a clear mathematical signature indicating its velocity was far too great for it to be a member of our solar system. It was on a one-way ticket just passing through. The global astronomical community immediately mobilized, and within a day, the Minor Planet Center officially designated it 3Y Atlas, confirming it as just the third interstellar object ever detected. While early images showed the familiar coma and tail of a comet, its origin story was anything but familiar. This was an artifact from another star system, a rare opportunity that our technology, far more advanced than during the 2017 flyby of Oumuamua, was finally ready to seize. The anomalous frame. This is the moment a routine observation devolved into a profound enigma. The final frame broadcast from NASA's feed, captured at precisely 03:1712 UTC, initially seems unremarkable. The faint glow of the comet's nucleus, enveloped by its gaseous coma, is set against the cold vacuum of space. But in the lower left quadrant, a detail emerges that just violates the natural aesthetics of a comet. It's a glint of light, but it's not diffuse or scattered. It's a perfectly straight edge, a sharp, geometric line. Physicists identify this as specular reflection, the kind of clean bounce of light you get from a polished surface, not the chaotic scattering produced by a chunk of fractured ice and rock. This observation immediately brought to mind the work of researchers like Harvard's Avi Loeb and his Galileo project, which actively searches for extraterrestrial technosignatures. Independent analysts quickly ran the image through edge detection algorithms, which confirmed the anomaly, a line segment about 37 pixels long, presenting an angle and sharpness inconsistent with any known natural cometary phenomenon. The data pointed to a chilling possibility, that the light was reflecting off something manufactured. Data verification. In an age of digital manipulation, the first question is always, is the evidence authentic? This is where the power of modern data integrity and citizen science comes into play. Before any official statements were made, a global network of independent archivists had already secured the data. These individuals run automated scripts that continuously download and mirror raw data feeds from space agencies. Within minutes of the blackout, copies of the feed from Australia, Germany, and the United States were uploaded to public servers. Each file, carrying the identical 03:1712 UTC timestamp, was validated with a unique SHA-256 checksum. This cryptographic hash functions as an incorruptible digital fingerprint. Altering even a single pixel would result in a completely different hash. When every copy was compared, they were all identical. The chain of custody was flawless, from NASA's original relay to the decentralized archives. This rigorous process proved the anomalous frame was not a hoax or a transmission error. The data is immutable, the archives are clean, and the mystery, as the celebrated astronomer Carl Sagan often emphasized, is therefore deserving of serious scientific inquiry because the foundational evidence is verifiable by anyone. Technical explanations. If the data is real, could the blackout be a staggering coincidence? To answer that, we have to look at the technology involved. NASA's communications architecture is, a global machine. It relies on the Deep Space Network, or DSN, with its massive radio antennas in Goldstone, California, Madrid, Spain, and Canberra, Australia. This system works in concert with the Tracking and Data Relay Satellite System, a constellation first launched in 1983, to provide continuous contact with probes and telescopes. Signal dropouts are a normal part of operations. As the Earth turns, a spacecraft will dip below the horizon of one DSN station, requiring a signal handover to the next. Sometimes this process, managed by engineers like JPL's Bradford Arnold, isn't perfectly seamless, causing a brief interruption known as a handover blank. These routine events are meticulously logged with specific reason codes. However, the outage at 0317 UTC, occurring at the exact second the anomaly was visible, did not have a standard handover code in the public logs. The official explanation cited general network instability, but the uncanny timing and lack of a specific technical fault code has left many experts and observers deeply unsatisfied. Digital forensics. Now let's zoom in to the pixel level, where the digital reality of the image is forged. Forensic analysis of the final frame revealed two critical clues that could point to a non-exotic explanation. First, the glint's straight edge aligns perfectly with the boundaries of several 8x8 pixel blocks. This is a telltale sign of how video compression algorithms like MPEG function. To reduce file size for transmission over vast distances, these codecs divide the image into a grid and can sometimes amplify or quantize a faint, noisy line into an unnaturally sharp, blocky one. The second clue involves cosmic rays. Deep space is saturated with high-energy particles that can strike a camera's sensor and overload a few pixels, creating a bright, transient streak that lasts for only a single frame. Digital forensics experts like Professor Hani Farid have documented how common these sensor-level events are in space imaging. Therefore, a leading theory proposes a double-hit scenario. A cosmic ray created a faint, linear artifact on the sensor, which was then exaggerated by the compression codec into the illusion of a perfect, solid edge. It's a plausible, purely technical explanation, though the brightness and consistency of the glint still push the boundaries of a typical artifact. 3i Atlas background. To truly grasp the significance of the anomaly, we must understand the object itself. Even before the controversial frame, 3i Atlas was a scientific puzzle. Detailed spectroscopic data from the James Webb Space Telescope, analyzed by teams including researchers like Martin Cordner at NASA's Goddard Space Flight Center, revealed a startling chemical composition. Unlike most comets from our own solar system's Oort cloud, such as the famous comet Hale-Bopp from 1997, which was rich in water ice, 3i Atlas was overwhelmingly dominated by carbon dioxide. It had a CO2 to water ratio of nearly 8:1. This means carbon dioxide ice, not water ice, was the primary fuel for its spectacular outgassing, creating a massive coma that stretched for hundreds of thousands of kilometers. This dense gaseous shroud completely hid the nucleus from direct view, with estimates placing its diameter at under a kilometer, comparable to the second interstellar visitor, 2I Borisov, which passed through in 2019. The Atlas survey's rapid scanning capability allowed for its early detection, giving us a precious opportunity to study it. This unique chemistry already confirmed it was an alien object, formed in a star system profoundly different from our own. Scientific scrutiny. In science, and especially in the search for extraterrestrial intelligence, skepticism is, well, the default position. Any extraordinary claim must survive a trial by fire. An anomalous signal in a single frame from one instrument is merely the starting point, not the conclusion. You see, the guiding principle is that extraordinary claims require extraordinary evidence. For the glint on 3i Atlas to be considered a credible techno-signature, it must be independently confirmed by other observatories using different instruments, preferably across multiple wavelengths of light. This is how science separates a true signal from instrumental noise or an artifact. As of now, the evidence remains on the lowest rung of this ladder of proof. We have a single, tantalizing data point, but no corroborating observations. Until the Hubble Space Telescope, the JWST, or major ground-based observatories can produce matching data, the majority of the scientific community, including veteran SETI astronomers like Jill Tarter, will urge caution. It's a slow, rigorous process designed to ensure that when a discovery is announced, it is built on a foundation of undeniable, repeatable evidence, preventing the kind of historical misinterpretations like Percival Lowell's belief in Martian canals. 3 theories. The debate over the anomaly has coalesced into 3 competing hypotheses. The first is grounded in conventional cometary physics. Comets are chaotic bodies. The intense solar heating experienced by 3I Atlas could have caused thermal stress, fracturing the nucleus and cleaving off a large, flat shard of ice or rock. The unusual glint could be nothing more than a brief reflection of sunlight off this newly exposed, highly reflective surface. The second theory points to a technological illusion. This is the Occam's razor explanation, suggesting the edge is simply a convergence of unrelated phenomena. A cosmic ray striking the sensor at a shallow angle, its effect amplified and distorted by the video codec's blocky math. It's a ghost in the machine. But the third idea, the one that challenges our assumptions about the universe, refuses to be dismissed. This hypothesis, echoing the speculative work of physicists like the late Freeman Dyson, posits that the object is exactly what it appears to be: manufactured. Perhaps it's a component of a self-replicating von Neumann probe, a fragment of a light sail, or a piece of a protective shell. The odds are admittedly long, but the data is just ambiguous enough to keep the possibility on the table. Broader implications. An event like this, a mysterious signal followed by an unexplained data blackout, has consequences that extend far beyond the astronomical community. It becomes a catalyst for public debate and a driver of scientific policy. The conversation shifts from what is that object to who controls the data and the narrative of discovery. It amplifies calls for greater transparency and the development of open-source data platforms, a principle that is driving next-generation projects like Chile's Vera C. Rubin Observatory. For the public, it's a powerful lesson in critical thinking, reminiscent of the global reaction to the famous 1977 WOW signal. That powerful, unexplained radio burst detected by astronomer Jerry Amon remains a cornerstone of SETI lore. This incident with 3I Atlas forces a conversation about our technological and psychological readiness for a potential first contact scenario. It challenges international bodies like the UN's Committee on the Peaceful Uses of Outer Space to consider protocols for such an event. It perfectly illustrates the tension between rigorous skepticism and the profound sense of wonder that fuels our exploration of the cosmos. The search continues. So, where does this leave the investigation? The official record is clear on a few facts. At 0317 UTC, the NASA feed was cut. The final frame contains a cryptographically verified geometric anomaly. The blackout's timing, while officially attributed to network issues, is highly suspect. As of today, no conclusive, peer-reviewed evidence exists to support an artificial origin for the glint on 3I Atlas. However, the search for answers is accelerating. Ambitious new missions are already in development, most notably the European Space Agency's Comet Interceptor. Scheduled for launch around 2029, this innovative spacecraft will park itself at a stable Lagrange point in space, essentially lying in wait for the next long-period comet or interstellar visitor to arrive. It will then be deployed for a close-range flyby, giving us our first high-resolution look at one of these pristine objects. This proactive strategy, championed by scientists like the mission's lead, Geraint Jones, demonstrates a paradigm shift in how we study these cosmic messengers. Every interstellar visitor is a gift, pushing our technology and our theories to their limits. The strange case of 3I Atlas remains one of the most compelling technological mysteries of our time. Caught between a plausible digital artifact and a discovery that could reshape the future of humanity. The verified data presents an anomaly, but the ultimate explanation is still out there, traveling through the darkness of our solar system. What is your analysis? Was this a ghost in the machine, a 1 in a billion natural coincidence, or our first fleeting data point from a technology beyond our own? Share your hypothesis in the comments below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the technology that is shaping our future. Thanks for watching InnoVision Tech.